In this lecture, we're going to try and balance this equation. You have this equation in front of you, and if you look at the number of atoms, they look balanced. There's one chlorine on the left hand side, there's one chlorine on the right hand side, there are four oxygens on the left hand side, and there are four oxygens on the right hand side, and the hydrogens are balanced. Everything looks balanced atom wise, but the problem comes would come if it's a redox equation. So we need to figure out all the oxidation states of all the elements and find out if this is a redox equation. So if you look at chlorine, chlorine is it's -1 over here. So the oxidation state of chlorine is -1. You have CrO4 -2, which in which case you need to find the oxidation state of chromium. So that is X, and there are four oxygens. So that's -2 into 4, and the total charge on the entire ion is -2. So X comes out to be, it comes out to be +6 in this case. So chromium is +6, and you have oxygen, which is -2, as we already know. Hydrogen is +1. That's pretty obvious. And again, I told you previously that chlorine was -1, but it is not -1 when it is bonded to oxygen. So over here, chlorine, the oxidation state of chlorine is it needs to be found out. So you have oxygen, you have chlorine, which is X, and you have oxygen, which is -2, and there are two of them. So the total charge on the ion is -1, and X comes out to be, it comes out to be +3. So chlorine over here is +3, and oxygen is -2. Similarly, chromium over here is again +3, hydrogen is +1, that's obvious, and oxygen is -2. So let's see if this is a redox equation. And you can see that chlorine, if I look at chlorine, it's going from -1 to +3. That basically means it's getting oxidized. So this is turning out to be a redox equation. Similarly, if you look at chromium, where's chromium? And chromium is going from +6 and it's going to +3. So it is getting reduced. So this is a redox equation. So we need to balance the number of electrons being gained and the number of electrons being lost. So first construct the equation for oxidation. And oxidation is Cl-1 is going from Cl-1 to Cl +3, so that is getting oxidized. And how many electrons is it losing? It's losing, it needs to lose 4 electrons to go from -1 to +3. So it has lost 4 electrons. And we need to construct an equation for reduction as well. So for this case, chromium is +6 and it is going to chromium +3. So it is getting reduced. And how many electrons is it gaining? It's gaining 3 electrons. But there's one thing that we need to balance the number of electrons gained and lost. So the only way we can balance the number of electrons being lost and the number of electrons being gained is we can multiply the above equation by 4. So multiply everything by 4, and not by 4 actually, this should be multiplied by 3 in fact. So this would be multiplied by 3 as well. So this comes out to be 12 electrons being lost, and we need to multiply this by 4. So this entire equation is multiplied by 4, so this becomes 12 electrons. So there are 12 electrons being lost and 12 electrons being gained. So now we have balanced equations. I can rewrite my oxidation equation, which should be 3Cl -1 and resulting in 3Cl +3 +12 electron. That's my oxidation equation. I need to once I have the electrons balanced, I need to start bringing in the atoms which are neither getting oxidized or reduced. So there are oxygen atoms and there are water molecules, plus there are hydrogen ions, which needs to be reintroduced in this entire equation. So the first thing is Cl -1 was actually just simply Cl -1, so that remains as Cl -1, and you have Cl +3, which was actually the compound where Cl plus 3 was found was actually ClO2 minus 1. So there should be 3 ClO2 minus 1 plus 12 electrons. Now one problem with this equation is that there are oxygen molecules over here. So the first thing is I need to balance the atoms now. I've balanced the number of electrons. Now I'm moving on to balancing atoms. So there are oxygen atoms over here on the right hand side, so there should be oxygen atoms on the left hand side as well, but the only thing in this entire equation that has oxygen is the water molecules. So how many water molecules should be put on the left hand side? In total there are 6 oxygen atoms, so there should be 6 water molecules on the left hand side. And if there are 6 water molecules on the left hand side, that would introduce an unbalanced equation. There are 12 H plus 1s as well. So since the equation has H plus 1, I can balance out the H plus 1s by writing 12 H plus 1s on the right hand side. So I can underline the things which I'm reintroducing into the entire equation. So there are 6 water molecules on the left hand side, 12 H plus 1 on the right hand side. And let's carefully see if this entire equation is completely balanced atom wise. There are 6 oxygens over here, there are 6 oxygens in this water molecule. And since there are 6 oxygens over there's 6 into 2, that's 12 hydrogen ions. There are 12 hydrogen ions on the right hand side. Now this oxidation equation looks completely balanced. Both electron wise, there are 12 electrons, underline that, and atom wise, I've balanced it. So let's move on to the reduction equation and complete the reduction equation. The reduction equation happened to be there were 12 electrons being gained by 4 chromium plus 6, and they were resulting in the production of 4 chromium plus 3 ions. Now I need to reintroduce everything back, the atoms which were neither getting oxidized nor reduced. I need to introduce those back into the equation. So let's go back and see what chromium plus 6 was actually. It was actually CrO4 minus 2. So let's rewrite this as 12 electrons plus, instead of chromium plus 6, I can write the entire compound, which is CrO4 minus 2, and that's resulting in 4Cr plus 3. Now the atoms need to be balanced, so there are 16 oxygen atoms on the left hand side. Since there are 16 oxygen atoms on the left hand side, there should be how many water molecules? There should be 16 water molecules on the right hand side. Now the oxygens are balanced. There's 16 oxygens over here, and there are 16 oxygens in 4CrO4 minus 2. So there's one thing still unbalanced, that's 16 hydrogens. I've introduced 16 hydrogens, 16, not 16, but 32 hydrogens over here. So I need to write down 32 H plus 1 ions. Be careful that I'm only introducing those things which were already present in the equation, H2O and H plus 1 ions. And let's carefully see whether this equation is balanced now. 32H plus 1, there are 32H plus 1 over here. 16 oxygens, there are 16 oxygens on this side. There are 4 chromiums, there are 4 chromiums, plus the 2 electrons are balanced. There are 12 electrons which we already balanced previously. So let's highlight this equation, and we would be working with these 2 equations. We can simply add the 2 equations up and we will get our overall balanced equation. So let's start writing the left hand side. I'm adding up the left hand side of the 2 equations, the oxidation reduction half equations. So you have 6 H2Os plus you have 3 Cl minus 1 plus you have 32 H plus 1 plus 4 CrO4 minus 2 plus I also have 12 electrons on my left hand side. On the right hand side you have 3 ClO2 minus 1 plus you have 12 H plus 1 plus you have 4 Cr plus 3 plus you have 16 H2Os, and you also have 12 electrons on the right hand side. One thing that is automatically cancelling out are the 12 electrons. Plus there are a few more things which are cancelling out. There's 6 H2Os over here, so that would become 10 H2O. And there are 12 H plus 1 over here, and there are 32 H plus 1 over here, so this would become 20 H plus 1. Now I have simplified this equation, balanced all the balance the electrons and balance the number of atoms, and I can rewrite the overall equation, which would now come out to be, it would come out to be 3Cl minus 1 plus you have 4CrO4 minus 2 plus I have 20H plus 1, and on the other hand side I have 3ClO2 minus 1 plus I have 4Cr plus 3 plus there are 10 H2Os. So this over here is my completely balanced equation. I've balanced the number of electrons gained and lost, and I've also balanced the number of atoms on the left hand side and on the right hand side.